Hello students, in this video I want to explain about the property of functions. So more than explain, just to review about property of functions. So in classes we already had the chance to discuss about the property of functions, and as I promised, right, I want to solve some exercise, right, about the property of functions, just to of course, help you to understand better this topic. So the first exercise that we have is about the intercepts, the domain, range, increasing, decreasing, constant intervals, and if the function is even or neither. So they say in in problems 25 to 32, so this is one of the problems, the graph of a function is given. Use the graph to find the intercept, if any, the domain and range, uh, the interval on which the function is increasing, decreasing, or constant, and whether the function is even, odd, or neither, right? So, well, let's then base it on the function given, try to answer these questions. So, first, intercepts. So, we know that we have x-intercepts, right? Uh, and you have those x-intercepts that are the points of intersection of the graph with the x-axis when y is 0, right? And we have those y-intercepts that are the points of intersection of the graph with the y-axis when x is equal to 0. So those points with coordinates y equals 0 are going to be x-intercepts. Those points with coordinates x equal to 0 are going to be y-intercepts. Also, we're going to be looking for those points where the graph is either touching or crossing the x and y axis. So obviously, we can see how here at minus pi over 2 comma 0 and at pi over 2 comma 0, the graph is crossing the x-axis. So we can say that we have x-intercepts at minus pi over 2 comma 0 and at pi over 2 comma 0. So these are the points where we have, the x-intercepts in this case. Now, y-intercept, of course, the y-intercept are those points where the graph is intersecting the y-axis. So we see how the graph is crossing through the y-axis at this point at 0, 1. So we say that my y-intercept is at 0, 1. Okay, so we found the x and y-intercepts. Now the next they say is the domain and range. So remember that to analyze the domain, you will go from the lowest x value to the highest x value. You will look at the extremes of the graph to make sure you know uh, what kind of symbol you have in the extreme. So if it's a closed circle, that means the point is included. If it's an open circle, that means that point is not included. And if it's an arrowhead, that means you know that the graph continues to infinity. Well, to analyze the domain, then I will go horizontally from the lowest x value to the highest x value. And obviously, we have the domain here from negative pi to pi, right? So in this case, domain, I will write the domain in interval notation. It will be from negative pi to pi. And in this case, we're going to use brackets because what we have in the extremes are these uh, closed circles, that are indicating that those points, are also that those values of x, so minus pi and pi, are also included as part of the domain of the function. Now, to analyze the range, we will go from the lowest y value to the highest y value. So analyzing the range makes me go, from the lowest y to the highest y. And then what is the lowest y value? We can see how the lowest y value is here, at minus 1, and the highest y value will be 1. So we can see how then the range of this function is basically from, -1 to 1. All my function is contained, right, in between those y values, right? So I can say now in interval notation that the range of the function would be from -1 to 1 using brackets, because we have closed circles, so that means that -1 and 1 are included in the range of the function. The next they ask you is to find the intervals where the function is increasing, decreasing, or is constant. So increasing, like C, decreasing, and then intervals where the function is constant, like C here. So increasing, obviously we know that the function is increasing in those intervals where the graph goes up when you analyze the function from left to right. So from this value of x equal to minus pi to x equals 0, we see how the graph goes up, right? So here we have the interval where my function is increasing. Is increasing from minus pi to 0, from x equals minus pi to x equals 0. Now, where is the function decreasing? The function is decreasing now from 0 to pi. In the interval from x equals 0 to x equals pi, we see how the graph goes downward, right, from left to right. Okay, also, we can apply those properties, that we discussed in classes that said that the function is increasing, right, when for x1 greater than x2, f of x1 then will be greater than f of x2. Or decreasing when for an x1 that is greater than a value of x sub 2, f of x1 will be lower than f of x sub 2. So two values of x, right, when you evaluate the x at your function, right, depending, right, on how is the values of the function, you will know if the function is increasing or decreasing. Okay, so as I said, then the interval of decreasing would be this interval that go from 0 to pi. And where the function is constant, well, in this case we have no interval where the function is constant, right? So the function is not constant at any interval, means it's not constant in any of the intervals given, right? So we have that the function is increasing from minus pi to 0, and the function is decreasing from 0 to pi. Now, they say whether the function is even or neither. So remember that we discussed in classes that a function is even when it is symmetric with respect to the y-axis. And we know that a function is odd when it's symmetric with respect to the origin. So in this case, it's evident that this function would be even. Why? Because the function is symmetric, right, in this case with respect to the y-axis. Okay, so for every point x comma y on your function, there is a point minus x comma y that is also in your function. So example of that, you have the function, the point pi comma minus y on pi comma minus 1 in your graph. Well, you have the reflection of that point, that is minus pi comma minus 1, the reflection with respect to the y-axis. You have the point pi over 2 comma 0 on your graph, you have the point minus pi over 2 comma 0 on your graph. So for every point x comma y on your graph, you have the reflection of that point minus x comma y also in your graph. So this graph is symmetric with respect to the y-axis. So this graph is the graph of an even function, right? So this is just the first that we want to discuss, right? When the function is even or odd, the intervals of increasing, decreasing, or constant, domain and range, and the intercepts. My next exercise is this. They say in problems 33 to 36, the graph of a function is given. Use the graph to find the numbers, if any, at which this function have a local maximum. What are the local maximum values? And the numbers, if any, at which the function have a local minimum. What are the local minimum values, right? So it's evident that we have, in this case, a local maximum at x equals 0, and the local maximum value is going to be 1, right? So local maximum at x equals 0, and local maximum value is y equals 1, right? Now let's go over the local minimums. So when we look at the graph, we have two local minimums, right? So we have local minimums in this case at minus pi comma minus 1, and we have another local minimum at pi comma minus 1, right? So we have here local minimums x equal minus pi with local minimum value minus 1, and x equals pi with a local minimum value also equal to minus 1. Right? So there we have, our local maximums and local minimums. So go to the book later and review, which are the conditions for a local maximum and a local minimum, right? So remember that when we are analyzing local maximums and minimums, right, we are taking only a piece of a domain, so we don't analyze the function in the whole domain, right? So they could be more maximums or more minimums, right? So we're analyzing just close to that value c, right? For which a f of c, if it's a local maximum, is greater than or equal to any f of x close to that value of x equals c. If it's a minimum, then f of c is lower than or equal to any f of x near to that value of x equals c, right? So just go to the book and you can just review the definition of local maximum and local minimum. Now, the next is just about determining whether each function is even or neither. So determine algebraically. So we know that to find if a function is even or neither graphically is pretty easy because it's about the symmetry. You find that the function is symmetric with respect to the y-axis is even if it's symmetric with respect to the origin is odd. But in this case, to analyze algebraically, we know that a function would be even if h of x is equals to h of minus x. And we know that a function would be odd if h of x is equal to minus h of minus x, or if minus h of x is equal to h of minus x, which is the same thing, right? These two conditions are basically the same. So let's get this function and let's analyze if this function is even. So we find, I already have h of x, right? So we compare with h of x. So we find h of minus x. H of minus x, we substitute the x by minus x. So we said minus x over, then minus x squared minus 1. So minus x over, then minus x squared is going to be x squared minus 1. So is this function even? It's not even. Why? because we see how here h of minus x is not equal to h of x, so not even, right? What are not equal? Well, because this function have this negative sign that is not in the other function, in the original function h of x. So we see how h of minus x is not the same that h of x, right? Because h of minus x have a negative sign that h of x doesn't have. Well, once you have, right, in this case, the value of h of minus x, and you find out, right, that the function is not even, right, it's now easy to evaluate if the function is odd, because you know that to have a function that is odd, right, what you have to do is to demonstrate that h of x, so the original function given, right, is equals to minus h of minus x. So you already know h of minus x, so the only thing you have to do to find minus h of minus x is to multiply the function you got here, you know, when you were trying to find if the function was even. So to get this h of minus x, and you multiply that by minus 1. So this is minus, and then what is the function? Minus x over then x squared minus 1, right? So when you multiply this, of course, you're going to get that negative times negative is positive, right? So you will get that this is x over x squared minus 1, and you see how now the function minus h of minus x is equal to h of x. So we have exactly the same function, x over x squared minus 1. So we see how this function is now odd, right? So as h of x is equal to minus h of minus x, we can say that the function is odd. So this function is odd. We got exactly the same expression, you know, of h of x and minus h of minus x. This is, you know, another important skill that you must practice in this part. Next that I want to discuss with you is about the absolute maximum and absolute minimum. Remember that we said that when we analyze now the function in the whole interval, we're going to look for those values, you know, of x, which, you know, you have the highest values of y if it's an absolute maximum, or the lowest value of y if it's an absolute minimum. There could be cases where you have no absolute maximum, you have no absolute minimum, or you don't have any of that. So no absolute maximum and no absolute minimum. So in this case, when we look at the function, right, this function over here, it has absolute maximum. So the absolute maximum is going to be this point, right? So you have an absolute maximum at x equals 3, and the absolute maximum value is y equals 4. Now, let's see about the absolute minimum. Well, in this case, we also have an absolute minimum, and this absolute minimum will be obviously this point over here. So you have your absolute minimum at x equal 1, and the absolute minimum value is also 1. Is y equals 1. Now, in the other case, when we analyze, yes, we have an absolute maximum. So this is our absolute maximum. So you have an absolute maximum at 2,4. So absolute maximum at x equal 2 and the absolute maximum value is 4. But when you analyze, this graph goes to negative infinity. So it keep going downwards forever, right? So we don't have absolute minimum. So absolute minimum in this case, none. Right? Because we have an arrowhead and that indicates that this graph continues going downward, you know, to negative infinity forever, so without limit, right? So that means that we don't have an absolute minimum in this function. So this is another important skill to identify given a function if have absolute maximum or absolute minimum. Now the next that I want to discuss with you, that I want to recall, is just about the average rate of change, right? And then in this case, they say find the average rate of change of a function that is f of x equal minus 2x squared plus 4 from 0 to 2. Remember that average rate of change would be f of v minus f of a over b minus a. So basically the average rate of change would be the slope of the line secant to the function f of x, at points x equals 0 and x equals 2. So now when we find this average rate of change, we know that if we have to find it, from 0 to 2, we will say a equals 0, b is equals 2. So if a is equals 0, f of a is going to be f of 0. So it would be minus 2 times 0 squared plus 4. So f of a would be equal to minus 2 times 0 squared would be 0 plus 4, it would be 4. So f of a would be 4. Now f of v, which is equal to f of 2, would be minus 2 times 2 squared plus 4, right? So it would be 2 squared is 4 times minus 2 is minus 8. Minus 8 plus 4, in this case, would be minus 4, right? So we get 2 squared is 4 times minus 2 minus 8 plus 4 minus 4. So f of v, or f of 2, would be minus 4. Now when I know f of a and f of v, I can say that f of v minus f of a over b minus a, which is the same that f of, what is f of v? F of 2 minus f of 0 over 2 minus 0, minus 0, is equal to, what is f of 2? We said that f of 2 is minus 4 minus, we said what is f of a, or f of 0 is 4 over 2 minus 0. So this would be minus 8 over 2, so it would be minus 4. So what is going to be the average rate of change from 0 to 2 for the function f of x equal minus 2x squared plus 4? Well, the average rate of change in this case would be equal to minus 4. So to calculate the average rate of change is not a big deal really, right? What we have to do is just to find the values of f of a and f of v, right? Whatever values a and b have, right? And then we later apply the formula to find this average rate of change. That is f of v minus f of a over b minus a. The next and last problem that I want to show you is this, where we have to find the average rate of change, and later we have to find the equation of the secant line containing the points minus 2 comma g of minus 2 and 1 comma g of 1. In this case, the function given is g of x equal x squared minus 2, and they want to find the average rate of change from minus 2 to 1. So the first would be to find the average rate of change. So I know that a is equals to minus 2, and I know that b would be equals 1, right? So g of a, which is g of minus 2, is equal to minus 2 squared minus 2, which is minus 2 squared is 4 minus 2, it would be 2, right? So g of a would be 2. Now g of v, which is going to be g of 1, right, in this case would be equal to 1 squared minus 2. 1 squared is 1 minus 2, that would be just minus 1, right? So once I have the values of a, b, g of a, and g of v, I can say that my average rate of change, g of v minus g of a over b minus a would be, what is g of v? We said that g of v is minus 1 minus what is g of a? We said that is 2 over what is b? 1 minus what is a? Is going to be minus 2. So I get minus 1 minus 2, which is minus 3. And then below I have 1 plus 2, which is minus 3 over 3, so which is minus 1. So I have that the average rate of change for this function is minus 1. Now later they ask you to find the equation of the secant line. So the average rate of change, g of v minus g of a over b minus a, that we said that is equal to minus 1, is equal to the slope of the secant line, right? So now we know that the slope of the secant line is just minus 1. Now we also know, right, that this point minus 2 comma g of minus 2 is the point minus 2 comma, what was the value of g of minus 2? Was 2. So it's minus 2 comma 2. So the point minus 2 comma 2 is a point, right, on the graph of g of x. Now the other point 1 comma g of 1 is 1 comma, what was the value of g of 1? It was minus 1, right? So we have 2 points that are on the function g of x, right? And basically my secant line, right, we pass through those points and we have a slope minus 1. So you want to find the equation of the secant line. You use the point slope form of the equation of the line. So remember the point slope form is y minus y sub 1 is equals a slope times x minus x sub 1. You know that the slope is minus 1, and then you can take any of the points, either this point minus 2 comma 2 or 1 comma minus 1. I would just take minus 2 comma 2, right, where this is x sub 1 and this will be y sub 1. So we say that y minus, what is y sub 1? Y sub 1, we said that it's going to be 2 is equal to the slope, which is minus 1 times x minus what is x sub 1? X sub 1 will be minus 2. So now we can say y minus 2 is equals minus, then x negative 2 will be positive 2. So we get y minus 2 equals minus x minus 2, right? Then now we're adding 2 to both sides, so y is equals minus x minus 2 plus 2. So minus 2 plus 2 is 0, so y is equals minus x. So here we got the equation of the secant line. So the equation of the secant line to the function g of x equal to x squared minus 2 at the point negative 2 comma 2 and 1 comma minus 1 would be y equals minus x. Y equals minus x. That is the equation of the secant line. So, my dear student, this has been just a review about property of functions. So, I have been trying to go over the main kind of exercise that we discussed in the last class, in the last two classes, where we had about the property of functions. Uh, I hope that with this review now you can just get a better understanding of the different type of exercise. It's super important that you study the theory, right? Because what I did is basically to solve the exercise without going over the definition of what is an absolute maximum or what is an absolute minimum, without going over the definition of what is a local maximum, local minimum, without going over the definition of domain or range, or without going over the definition of increasing, decreasing intervals. So I just solved the exercise, assuming that you already understand those definitions, right? Because we had already one class about this. So uh, if you already studied those definitions, it will be easier then for you to understand, how we have solved all these exercises. So thank you so much for your attention, and I hope that this video will be very useful for you. Have a very good day.